All right, let's look at lesson 3, which is the Bohr model. So Bohr models, how do electrons orbit the nucleus? We talked about how Bohr came up with this idea when we talked about the atom in Unit 3, that Bohr had a centralized nucleus with electrons around the nucleus in these orbits. But they're actually in energy levels. So these orbits are energy levels that are going to be outside the nucleus. Each principal energy level is a fixed distance from the nucleus, which means it doesn't change. It can hold a specific number of electrons, and it has a definite amount of energy that can be calculated. The greater the distance from the nucleus, the greater the energy level the electrons have in it. So, as we look at this, energy level 1, 2, 3, 4, as we go up, the energy is going to increase. So the orbits are called the principal energy levels, or shells. You'll hear me call them both, energy levels and shells. So that's, remember, the orbitals that are around it. So the paths that the electrons travel. So how many electrons can each shell hold? The equation to solve for it is 2 to the 2n to squared. So that means n is the period number from the reference table. So either 1, 2, 3, or 4. So, for example, the maximum of electrons in the first energy shell would be 2 times 1 squared. Well, 1 squared is 1 times 2, so 2 electrons can fit into the first energy level. So, instead of having you calculate it each time, these are just things you're going to have to memorize. So in energy level 1, you can have 2 electrons. In energy level 2, you can have 8 at a maximum. That means you can't have any more. Energy level 3, you can have 18. Energy level 4, you can have 32. And energy level 5, you can have 50 electrons at a maximum. So, how do you draw Bohr diagrams? You first need to look up the electron configuration on your periodic table. Remember, if it's an ion, you're going to have to add or subtract electrons from the outermost energy level. So here's a blown up picture of your periodic table. This down here is your electron configuration for the Bohr model, and the Bohr model only. So this tells you have 2 for lithium. You have 2 electrons in the first ring and 1 electron in the second ring. So you're going to draw a center for the nucleus and notate the number of protons and neutrons in it. So you need to tell me how many protons are in there, how many neutrons are in there. Then you're going to draw the energy levels, rings around the nucleus, and notate the number of electrons that are in each cell. So let's look at this for lithium. So lithium has an atomic number of 3, so that means we have 3 protons. Its mass is 7, so if we round that up, the mass number is 7, so that means it has 4 neutrons. And we have 2 electrons in the first energy level and 1 electron in the second energy level. So this is what your Bohr diagram of lithium would look like. Okay? Based on our periodic table, magnesium has 12 protons. The mass is 24, so that means it has 12 neutrons. It has 2 electrons in the first energy level, and it has 8 electrons in the second energy level. It should have 12 electrons, but this is an ion, so it's going to be different. What about for sodium? Sodium is going to have 11 protons in the middle. Now what about for sodium? Sodium's going to have 11 protons in the middle, 12 neutrons in the middle, and then it's going to have 2 electrons in the first ring, 8 electrons in the second ring, and 1 electron in the third ring. Now what about for hydrogen? Hydrogen's Bohr diagram is kind of boring. So it has 1 proton in the middle, and it only has 1 ring with 1 electron on the outside. Alright, so let's see. Let's see if you can draw the Bohr diagram of sodium on your own, and we're going to check that in class tomorrow.